Alright, today we're going to look at balancing redox reactions. First we're going to review in an acidic solution, and then we're going to look at a basic solution. So to review for the acidic solution, first thing we do is break the one reaction to two halves, so dichromate ion and the chromium ion, and then C2H5OH to the CO2. Then we want to balance our non-oxygen or hydrogen atom. So since we have two chromiums on the left, we would need two on the right. Same with the carbon. We have two on the left, so we'd have to multiply 2 to get 2 on the right. And then we balance our oxygens by adding water. So I have 7 oxygen on the left, so I would need 7 waters on the right. On the bottom, we have 1 oxygen on the left, and we have 4 oxygens on the right. So we would need to add 3 waters to the left-hand side. And then we balance our hydrogen by adding hydrogen ions. And then, so we have 7 times 2 makes 14 hydrogens on the right. So we would need 14 hydrogen ions on the left. We have 6 hydrogens on the left, plus we have 6 more here. That makes 12. We don't have any on the right, so we'd have to add 12 hydrogen ions. Then we balance our electrons. So we have 14 positives, or balance our charge by adding electrons. We have 14 positives and 1 negative. That makes a plus 12 on the left. Then we have 2 positive 3s, and of course the water has no charge, so that's a plus 6. So to balance our electrons, we need to add enough to make the more positive side equal to the other side. So we would need 6 electrons since they are each negative. And then we do the same thing on the bottom. So we have no charge here on the left. On the right, we have 12 positives. So again, we need to add enough electrons to the right-hand side to make it equal to the left. So that would be 12 electrons. So then we have to make our electrons equal to each other, since our electrons are not equal. So we would do that by multiplying the top by 2. Right? And then remember, we have to multiply everything in there by 2. So I'm going to rewrite that on here below. So we have 12 electrons plus 14 hydrogen ions plus a dichromate ion goes, 2 is 12, and then 28, and then 2 dichromate ions, and then we would have 4 chromium ions and 14 waters, because we have to distribute that 2 to everything. Alright, so then our electrons are equal, so now they would cancel out. We would also be able to cancel out our, or reduce anyway, our waters and our hydrogens. So since we have 3 waters on the left and 14 on the right, 3 on the left would go away. We would subtract 3 from the right, and that would leave us with 11. And the same with the hydrogens. We have 12 on the right and 28 on the left. The 12 on the right would go away, and we would subtract them from the 28, and that would leave us with 16. So let's rewrite that answer. So we would have C2H5OH plus 16 hydrogen ions plus 2 dichromate ions gives us 4 chromium plus 3 and 11 waters and 2 carbon dioxides. Alright, so that's balancing in an acidic solution. If we counted up, we would see we have an equal amounts of everything. So we have 2 carbons, 6 plus 16 is 22 hydrogens. We have 22 hydrogens here. 4 chromium. Our oxygens are 14 plus 1 is 15. We have here 11 plus 4 makes 15. And even our charges add up. We have 16 positives plus 4 negatives is a plus 12, and 4 times plus 3 is a plus 12. So we know we did that correctly. So that's what we've been doing with acidic solution. Now for a basic solution, there's just one more step. We go through all the steps we just did, and once we've balanced an acidic solution, then we add enough hydroxide ions to be equal to the number of hydrogen ions. So since I have 16 hydrogen ions, I add 16 hydroxide ions. Now every good math student knows that what you do to one side of an equation, you have to do to the other side. So we have to put 16 hydroxides on the other side as well. These 16 hydrogens and 16 hydroxide ions and hydrogen ions, they come together over here and make water, and make 16 of them. So now these two have formed water together. So we have 16 waters on the left and 11 waters on the right. So those ones on the right, they cancel, and we subtract them from the ones on the left, and that leaves us with 5. And then we write our final answer. So we have 5H2O plus C2H5OH plus 2 dichromate ions, go to 4Cr plus 3, 2 carbon dioxide ions, and then 16 hydroxide ions. And again, we can count. We have, make sure we're equal still. We have 10 hydrogens plus 6 more makes 16. Over here we have 16 hydrogens. We have 2 carbons, 2 carbons. We have 1 plus 14 makes 15 oxygens. 15, and then 5 more here is 20 oxygens, and we have 16 plus 4 makes 20. And so you can see we are all balanced still. Let's look at one more for basic solutions together. So this one, we have only one reactant. When we have only one reactant, we just use it twice. So we have 1/2 reaction has the chlorines going to chloride, and one where the chlorines are going to hypochlorite ion. And then from there, we just do everything exactly the same as we've been doing. So we balance our non-oxygen hydrogen atom. That's our chlorine, so we multiply by 2. Same here in the bottom, multiply by 2. Since there's no hydrogen or hydroxides in the top, and waters in the top, we don't need to add any water or hydrogen ions. We just need to balance the electrons up here. And so since this side is 0 and this side is -2, that means we would add electrons to the more positive side, and enough to make them equal to the right. So it'll be 2 electrons then on the left. Now on the bottom we have oxygen, so we have 2 here. We don't have any over there, so we would have to add 2 waters, which would then give us hydrogen ions. So then we would have to add 4 hydrogen ions to the right. And then we would have to look at our charge. So again, we have 2 negatives and 4 positives is a +2. And then on the left side we have 0. So again, we need to add enough electrons to make our more positive side equal to our other side. In this case is 2 electrons. Since our electrons are already equal, we don't have to balance those. So we can just cancel them out. We do not have any hydrogens or waters in the top, so those won't cancel. So then we just write our answer, H2H2O. Since there's 2 of these, we add them together, it'd be 2Cl2. Go to 2Cl minus plus 2OCl minus and 4 hydrogen ions. So if we were doing an acidic solution, we would stop there. But since today we're focused on a basic solution, we're going to then add our hydroxide ions. Remember, we add enough hydroxide ions to be equal to the number of hydrogen ions. So since there's 4, we would add 4 hydroxide ions, again, to both sides of the equation. Again, the ones with the hydrogen form water, so we would have 4 waters on the right. And then we would need to subtract out our waters, right? So we have 2 waters on the left, so those will go away. These would reduce down to 2. And our final answer would be 4 hydroxide ions plus 2 chlorine, go to 2 chloride ions plus 2 hypochlorite ions plus 2 waters. And that would be balancing redox reactions in basic solutions. So again, once you've gone through the process of balancing, you balance in an acidic solution first, go through all those steps, then you add hydroxide ions equal to your hydrogen ions to both sides. Right? On the side that our hydrogen and hydroxide ions are together, our hydrogen and our hydroxide ions together. They equal to water, right? And then you cancel and subtract your waters. Okay? And that's how you do it.